Hello, everyone. Welcome to e-learning. So our subject today is natural sciences, and the topic is the elements of the periodic table. This is for grade 7, term 2. So you're going to ask yourself, what is a periodic table? What are elements? What are we talking about? Now, you know that everything around us is made up of matter, and all matter is made up of elements. Now, matter comes in different forms, as you've learned in previous grades. It comes in solid, liquid, or a gas. Now, all of these things, whether it is a solid or a liquid or a gas, they're made up of atoms. Now, atoms are the smallest units of elements, and each element is listed in the periodical table. All the matter is made up of these elements, and it is in its purest form, or it is a compound. Now, we know that if we put elements together, that means if we mix two elements together, they will form new material. That that is called a compound. Like for example, water. If we take two hydrogen atoms and mix it with an oxygen atom, then we get water. Now, the keywords that you need to know for this section is elements. This means it is a pure substance that it cannot be broken down any further. Matter is basically everything around us. Then we need to understand the two words, periods and groups. Now, in this context, period means it is a horizontal row that is going horizontally across the periodical table. And then we have groups. Groups means that these are vertical columns that is going down the periodical table. I'll show you a picture just now of the periodical table and explain the period and the group to you in greater detail. I know it's a little confusing because in school a period means one lesson and a group means a group of children sitting together learning. But remember, in the periodical table, period means rows, horizontal rows, and groups mean vertical columns. Right. So in this topic, we're going to learn about how the elements are arranged in three groups, which is metals, nonmetals, and semi-metals. Now, the periodic table basically are all the elements. It's put together in the periodical table. It is organized in such a way that it is put into groups. And some of the three groups is the metals, non-metals, and semi-metals. Now, each element is unique and it possesses distinctive properties, and this includes melting points and chemical reactivity. Melting point is when, like, for example, if you melt gold, there's a certain melting point for it to go melt. Or chemical reactivity is when you put two elements together and it reacts. Then, like for example, if you take Mentos and you put it into Coke, then it's going to explode. So that's a chemical reaction, for example. Now, one of the examples is sodium conducts electricity, and it melts at 98 degrees Celsius, and it is very reactive. Now you want to know basically what are materials made up of. Materials are basically things that you can see and touch, and this is called matter. Matter is made up of materials, and all the materials are made up of elements. An element is basically a pure substance, it cannot be broken down simpler. And the person that um, organized a periodical table was Dmitry Mendeleev, and he created it in the 1800s. But what he did was that he left blank spaces in the initial periodical table because some substances had elements hadn't been discovered as yet. And he arranged these elements according to their properties, and as he arranged them, he noticed a pattern, and that's a picture of him at the bottom. Right, so this is what I'm talking about. This is a periodical table. So when I was telling you about the periods and the rows, the horizontal lines. Like for example, if we look at the fourth row, we looking at KASC. Okay, let me just say the names: potassium, calcium, sodium, for example. Now that is the period. Then the groups are the columns going down, like where we have hydrogen, number one. These are the groups, right? So let's look at how these are arranged. Now, um, okay, so we're going to move on. Now, each element has a specific name. Like, for example, you had hydrogen. Then we have the symbol for hydrogen. It is H. That is called the chemical symbol. And then it has an atomic number and a mass number. And that tells you how it is arranged in the periodical table. The atomic number helps you find the element because the atomic numbers increases from left to right across the rows. So you can see here. Now you have hydrogen. Now that is the only non-metal that is in the metal section. Now the metal section is all the ones that are pinkish. The semi-metals are greenish and the non-metals are the yellow. So hydrogen is a non-metal that is the first number in the periodical table, so it's number one. Now if you that is on the left. Now if you look right to the right, now in that row you get helium, and that atomic number is 2. Then in the second row you get number 3, which is lithium, and then beryllium, which is number 4. So the atomic number is 4. So you can see the atomic numbers here is at the top, the mass number is at the bottom, and then the element is at the center. Now this block shows you the element for nitrogen that is in the periodic table. Right. So the three main categories of these elements, as I said before, it was metals, semi-metals, and non-metals. Metals are arranged in the middle from left to right, which I showed you. Now, non-metals are found in the far right-hand corner of the periodical table. You can see here that that is the yellow part. And the semi-metals is that it is in between the metals and the non-metals, and it kind of forms a zigzag fashion pattern that you can see here, barren, and then I can't see the names because it's a little small, but all the green ones are the zigzag patterns, and that is the semi-metals. Now, the key concepts that you need to know is that the elements are arranged according to their properties. Each element has a name, a symbol, an atomic number, and a specific position in the periodic table. And it is divided into three main categories: metals, semi-metals, and non-metals. And I classified them for you because in grade 7 you need to know by heart the first 20 elements of the periodical table. So the metals you need to know: lithium, beryllium, sodium, magnesium, aluminium, potassium, and calcium. Then a semi-metal is boron or boron, and the non-metals are hydrogen, helium, carbon, nitrogen, oxygen, fluorine, neon, phosphorus, sulfur, chlorine, and the one that I can't see that's blocking that. Right. So let's look at the properties. Now you get these keywords that is called ductile and malleable. Ductile means that it can be stretched into thin wires, and malleable means that it can change its shape. For example, it can be bent or it can be flattened into thin sheets without breaking. Now, from the periodical table, you can see that most of the elements are metals and few of them are non-metals. And even fewer of them are semi-metals. So it's important to know that the properties of metals, semi-metals, and non-metals, so you can distinguish how to make new materials. Like for example, if you take two metal aluminiums and a titanium to make an aeroplane, It's because the metals are solids and it's strong and it's light. And an aeroplane that is made out of iron is going to be too heavy to fly. So you need light elements that's going to make an aeroplane. It needs to be aerodynamic, so it needs to be light, so it can move through the air with a faster speed. Now, metals that are shiny are ductile and malleable. Like, for example, the solid, except for mercury. Now, these have high melting points, and the non-metals have very different properties, and that depends whether it is a solid or a gas. Now, let's look at these metals and non-metals. So, if you look at the state of matter, most of the solids, except for mercury, are liquid. And gas you get them as in this bottle here, you get solids, liquids, and gases. Now, conductors of electricity, you need to know whether it's a good conductor or a poor conductor. So if you see this circuit, the nail that is joining or completing the circuit is a good conductor of electricity, so it's a metal. Now, the poor conductor of electricity is a non-metal, which is the wood at the bottom. Okay, so let's look at conduction of heat. So the metal here is a good conductor of electricity, and the plastic is a poor conductor of electricity. With a magnet, the metals are such as iron, cobalt, and nickel are magnetic, and they're good conductors of electricity. And non-magnets are bad conductors of non-metals are not good conductors of electricity. So you must look at their appearance. So metals are normally shiny, non-metals are dull. Metals are malleable, that means it can bend without breaking, and the metals can take different shapes easily. Like non-metals, like for example glass, it's in its solid form, that means that it can break easily and it's brittle. And like for example, if a glass breaks, you're going to get cut. Ductile means it can be stretched into a thin wire, and a non-metal cannot be stretched. Melting points in a metal, most metals are solid at room temperature, and at melting points they become liquid. Then non-metals, they have a low melting point. Not many non-metals are gases at room temperature. So it's important to know this information because I can ask to you in the exam, and I can ask you the characteristics or list the properties or states. I can give you a picture. I can ask you, is it a metal? Is it a non-metal? Why is it ductile? What is the melting point? And questions like that. So semi-metals basically are found between the metals and the non-metals, and they include barium, silicon, germanium, arsenic, antimony, and beryllium. And properties of semi-metals basically are they have the same properties of metals and some non-metals. They are solid and they're shiny like metals, but they can also be brittle and they break easily like non-metals. Now they are can conduct electricity, but not as well as metals, and they are therefore called semiconductors. Now the uses of semimetals, like for example silicon, is the most common semi-metal, and these make up glass, microchips. Microchips are used in computers and cell phones and radios. Then you get optic fibers, and that is used for the internet and wireless communication. You have germanium and boron, which is shiny, but they are also brittle, and these are used in electronics. Germanium, antimony, and beryllium, they are used to make rewritable DVDs. Interesting facts is that optical fibers, they are thin glass tubes made up of silicon and germanium. They are very light and strong, and they're perfect for carrying data over long distance. I hope you like the video. Please go over it, learn it. Most of it you'll be tested in the exam. Bye. I'll see you in my next video. Enjoy the rest of your day. Don't forget to like and subscribe.